Good morning. I hope you had a good weekend. Yes, thumbs up. Woo. Awesome. This morning I want to talk about architecture for your iOS app. And that's a topic that comes pretty early. A lot of you, I know, haven't really started on the app yet. But I think it's important to give you an idea of things you should try to do in your iOS apps and things you should try to avoid. Because once you get started and go off in one direction, it's really hard to fix that stuff. So I want to give you just a high-level overview of, firstly, a few concepts you should keep in mind when considering where to put which code, and secondly, also some practical tips that you can look out for. So first, briefly, I want to talk about the goals of software architecture in the first place. That's kind of the why should I care category. Then about some general design guidelines, and then, as I said, some practical tips of things you can do in your iOS apps. So the first important goals of software architecture is actually to make your code comprehensible for other developers. In this scenario here, you're developing the apps on your own, but later in later semesters, and especially in the workplace, you will constantly be working with other developers. And if your code is easy to understand, then it makes it easier to work with other people. That's actually a very simple concept. And easy to understand for others also means easy to understand for you 6 months from now or 12 months from now. If you have ever had a project for that long of a period of time, you'll realize that it's easy to have no idea of your code base if you didn't look at it for a longer period of time. That's actually how I lost my first private project. I started when I was like 16, building this huge app, and then there was a summer break of 2 months, and then I came back and I didn't understand my code anymore, and I didn't know where I had stopped. And that was basically the project was over. I didn't have the persistence or ability to recover it anymore. So yeah, in general, the goal is to keep it comprehensible. Also, if you have designed your code well, it is easier to adapt to changes. If you actually have an app that you want to maintain for a longer period of time, there will be features added, there will be features removed. The better your code is designed up front, easier it is to do that. And another goal is to share code within a project and throughout different projects. Once you start building multiple iOS apps, you'll realize there are a lot of problems that you maybe solved before. If you structure the code well, then you can actually extract one of your components and reuse them in a different project. Okay, let's go into some concepts. The first one is what I want to talk about is some of the misconceptions behind object-oriented design. So if you had that in school before, or if you read about object-oriented design, then you kind of have this idea of objects, for example, user objects or trip objects in our particular app, and you think that these objects should encapsulate basically all different behavior that belongs to that specific object. So what you might do is add a user object or a trip object, and then add the UI code for that user object, add the persistence code for the user object, and add the networking code for the user object, and put it all into a user class. Because that is kind of what you think object-oriented design is about. Thinking about real-world objects and then putting all the code in there. But in reality, it's much better to think about the different domains that you have in your app. You have UI code that is totally different from networking code, for example. You have code that talks to a database, which is also totally different from UI code. And if you think in these domains, then you'll see that there is some that are basically the same for all types of objects, and some that are object-specific. And that's how you should kind of structure your code. For example, the UI code will be very specific for each different type of object. But you don't want to have a user object that knows how to talk to a database and also knows how to represent itself on screen. Instead, you want a user view that is simply responsible for displaying a user. And then you want a code that is related for persistence or networking in a separate class. So if you think about how to divide your code, you really want to think about the different domains that you have. What are the different types of things each object should do? And then think about whether the code can be shared between all objects, which is typically true for networking and persistence, or whether each of the object needs a specific class, which is more typically true for the UI code and for what we call the business logic. Business logic is just a term for the application logic, like what happens when a user enters a trip. Is it stored in a database? Is it verified? Is it sent to a server? That is kind of the business logic. So think in these domains and then try to divide your code amongst them. That's just a high-level idea. Another one is what we call a single responsibility principle. And that's also something very abstract, but once you understood the idea behind it, when you write code, you can think about whether your code fulfills this principle or not, and it gives you a good kind of rule of thumb on how to structure your code. The basic idea is that a class or any unit of code should really be responsible for only one thing. Many cases that's really hard to accomplish, but you should try to strive for it anyway. The most typical example where you will encounter this in iOS apps is when you implement a UI view controller subclass. And because it's so important, I have a whole another section talking about that. But if you think about a view controller, if you've done iOS before, it's basically that one class that handles user interaction, that handles displaying things, that often also handles talking to your business logic. And if you have a bad view controller, then it actually implements all of these things. So a view controller might talk to a database, it might implement the actual logic of your app, it might also implement some view code. And if you have such a view controller, then it's violating the single responsibility principle because it's doing 5 things instead of 1. The goal would be to basically take out the different things and put them into separate classes. So have a separate class for things that work with database, have a separate class for the view, have a separate class for the business logic, and have the view controller be very simple. So the idea is, if you write a piece of code, try to think about if it does one specific thing, for example, displaying something on the screen, or if it does multiple things, for example, display on the screen and talk to the database. If it does more than one thing, try to think about how you can divide it up. Along similar lines, I also want to talk about encapsulation. Encapsulation means that each of your units of code know as little as possible about other units of code. That makes it easier to replace these classes, for example, with other classes, and also makes it easier to change a particular piece of code in your app. Because if you don't have that, if you have interdependence between different classes, for example, then you might not know anymore, like 6 months from now, which class actually depends on which other one. And a change in one place of your app will maybe affect 10 different other places. So what you want to avoid is having these dependencies in the first place. If possible, each class should be as isolated as possible from other ones. So how can you accomplish that? Mostly through small interfaces for communicating between these different classes. I have a little example here. Let's say you have an add trip view controller. So later in your app, you're going to add a view controller that allows the user to create a trip and save it. And because you want to have the single responsibility principle, you have a separate class that actually talks to the database, which I called a core data client in this case. Now, a bad interface would look somewhat like this here, where you say, OK, as soon as someone taps a button here, I'm going to start saving a new trip. And then the database is going to set, the view controller is going to set a property on the database that basically saves the name of the trip. And then the database is going to respond with an error message and is going to say, display this error for me. And then the client is also going to respond and say, please disable the save button because the name that was entered is incorrect. So there are kind of 4 steps of communication going on here between the view controller and the database. It's saying start to save it, and then the database says, oh, the name was actually incorrect, so display the error. And then the database even tells the view controller to disable a button. So here the database knows about a button that is displayed on this view. So both parts of this code know a lot about the other classes they're talking to. And that is very bad. The database should never know about the button that is displayed here. Because if the button is removed, then the database class also needs to be changed. Ideally, you want to change only if you happen in here. Now, this totally ineligible text here at the bottom says that the classes are poorly encapsulated, and they're very dependent on each other. So the more they know about each other, the more they depend on each other, and the more changes in one class will break the other one. What would a better interface look like? This here is a better solution. We have, again, the 2 same components, but we only have a single way of communicating between them. And that is the add trip view controller calls a save trip method. As soon as it has all the information about the trip, it tells the database that it wants to save it. Then the database verifies the result, and it returns whether it was successful or whether an error occurred. And then once the view controller gets this error from the database, it is responsible for displaying it on the screen. And then it can decide to disable the button or to do any other kind of stuff. But it's no longer the database telling the view controller to hide a button. Instead, the database does its job of verifying the entry and, if necessary, returning an error message. But the view controller knows itself how to handle this error and how to display it and how to change the user interface based on it. So the difference between these 2 approaches is more or less clear. Any questions around that? So in one case, the database talks to the view directly. In the other case, the database returns an error object, and the view itself handles displaying that. So let's dive into practical tips about how to avoid common problems in your iOS apps and how to structure certain aspects. So the first one, that's really the most important one because that's the issue that most beginners run into, and that is called avoid the massive view controller. So in general, if you start writing iOS code and you create a bunch of view controllers, take a look at them, and if any one of them has more than 300 lines of code, it's really just a stupid rule of thumb, then it's most likely doing more than it should do. In my cases, I mostly get view controllers down to like 150 lines or 200 lines. If you just start writing iOS code without thinking about this kind of stuff, then you might get a view controller that has 2,000 lines of code. So if you have more than 300, it's generally an indicator that you're violating the single responsibility principle because your view controller is doing more than one thing. So what should a view controller do? Essentially, a view controller is the part that connects your views, the things that are displaying something on the screen, to your business logic and your database. So all it should really do is listen to callbacks from the view. So for example, when a user taps a button, then the view controller should listen to that. If that happens, then it should invoke some kind of method on the model layer. So let's say someone hit a delete button, then it should invoke a delete message on the database. Then it should wait for a response on the model layer, and once it gets that, it should refresh the view with the new data. So it just takes inputs from the view, talks to the model to basically activate the corresponding action, wait for the response from that action, and then update the view. So it's just an arbitrator between the different components. Things you should not do is construct complex network requests, or complex database queries, or serializing or deserializing objects. All such kind of stuff should not happen within the view controller. You might have a view controller that wants to download data, but then the code that actually does the download should not be within the view controller. It should be within a different class that is taking care of downloads. Second one is defining expressive APIs. Whenever possible, you should try to, once again, encapsulate code and put it into a nice API. So let's say you want to download all the users in an app, and you want to call this code from a view controller. A not so nice way of doing that would be having all the networking code in the view controller. A better way of doing it would be having a separate class that provides a function called fetchAllUsers, and all it does is provide a callback method that gets an array of users. Yes?
Can you place error handling in the view controller?
The error handling can be in the view controller, but it depends a little bit on what kind of errors you're handling. So I would say it has to be split up usually. Okay. So some error handling that has to do with the database should have some of the errors handled before they come to the view controller. Right. And the view controller should only get a portion of the error that is actually displayed to the user.
Okay. So if, say you fail fetching all users, you would have the errors, and you would check if the errors exist or not, and that's fine if you place that in the view controller.
Yes, in general that would be fine, but I would say there are two categories of errors. Some that are displayed to the user and are relevant to the user, and some that are not relevant to the user. And depending on that, you should place them in the view controller or not. Okay. The view controller typically only anything that would be relevant to display to the user. Okay, and then once you have defined such an API, the view controller can simply call a method called fetchAllUsers, and it will get back a list of users. And that is very clear intent. It's very nicely isolated. And if 6 months from now you come back and look at this code, you see, okay, what is the view controller doing? It is apparently trying to fetch all the users. And if you have such nice self-explanatory code, you don't even need comments. Because you basically have such small functions that have such good names that just by reading the function names, you will have a good idea of what is going on. So try to hide the complexity of, for example, a network request behind a very simple API, and then call these simple APIs from your view controllers. Have that complex code live elsewhere. Another good thing to do is using view objects. The idea behind view objects is that they encapsulate multiple properties that you want to display in a view. And it's really a much better way of basically setting up a view instead of setting individual properties. Short example in code. Let's say you have, again, simple example is a user view, and you want to display information about a user. In this simple example, we just have two pieces of information. One is a username, and the other one is a profile picture. You could have a much more complex user view. In most apps, you're probably going to have 5 properties. But the structure here is that that user view actually takes a user object. It has a property called user, and it has a didSet method. Now, when any kind of view controller or any other piece of code sets up this view, all it does is it passes in a user object, and the code here is set up that as soon as it receives a user object, it will configure the label and it will configure the image view that shows the profile picture. So it receives a full object, and then it configures itself based on that object. That means from the outside, all you do to actually set up this view is call userView.user equals current user. The counterexample of doing it in a not as nice way is the user view actually just exposes the properties as, for example, the label and the image view. And the piece of code that configures this view knows about the label and knows about the image view and sets it directly. So this is the negative example. This is how you don't want to do it. Because in this case, firstly, you have 2 lines. So the view controller has to know about the label, and has to know about the image and set it. But secondly, you're again violating encapsulation. Any piece of code that wants to set up this view now knows about all the individual view components. It knows that there's 1 label, 1 image view, and as the app grows, it knows about all components that you have. And it's purely isolated, which means if you remove the label here, for example, then all code that talks to this view and sets up this view has to be changed. In all places, you'll have to remove references to that label. Whereas in the first example, when you pass in a user object and just say, hey, view, render yourself based on this user object, then you can change the view however you want, and the code will still work. You can replace labels, you can add more labels, and the API that works together with that view will not have to know about it because it's just passing in a user object and lets the view render itself totally independently. Clear? So basically along the lines of everything I talked before. The fourth one is a little bit different, and it's also particular more to Swift than to other programming languages, and that is called be wary of inheritance. So inheritance is typically a way of how you share code between different classes. And the main idea behind inheritance is you have 5 things that are very similar to a different thing, so let's create a base class and then use inheritance to share code between them. But inheritance also has a big drawback, and that is, in most languages, including Swift, for very good reasons, you can only inherit from 1 single class. So for example, if you have a base view that has a lot of things that are in common for different views, then if you want to inherit from it, you can only inherit from 1 single class. You can't inherit from multiple classes. That means you can't adopt multiple functionalities. What it means is if you inherit from a view, then you are a view. If you have code that you want to share, for example, for logging or for talking to a database, then you have to decide whether your class is a view or whether it is a database object or whether it is a logging object. But it cannot be 3 things at the same time if you use inheritance. There are actually more modular alternatives of sharing code. And these are functions, just free functions that can work with different types. We're going to talk about that more separately. But more importantly, as a very good alternatives, protocols. So protocols you can actually use multiple of, and not only one. And if you have this example here where you have a view that should be able to represent an error, that should be able to be restored as soon as an app opens and closes, and that should be presentable in a log message. So these are just examples of different features you could have. Then you could create a protocol for each of these feature sets, and you could have your classes implement multiple of these protocols. So here you can basically adopt 3 pieces of functionality, whereas in this example, using inheritance, you can only inherit 1 set of functionality. Another good part about this modularity is that you don't inherit things that you don't need. So when you inherit from, let's say, a UI view, then you inherit 50 properties and 100 methods. And your view might only need 3 of them. And it makes it really hard for developers to understand which are the methods that are actually necessary for your view, and which are the ones that you inherited that you actually don't even need to use. That typically tends to happen with inheritance. With protocols, you can actually define very, very small protocols that only have 1 or 2 functions, and then only basically by looking at all the protocols you adopt, you already know which functions you use. And if you don't need a function, then you remove it into a separate protocol and you just don't adopt it. So typically when using protocols, you will have only the methods in your interface that you actually use, whereas when you use inheritance, you might inherit things that you don't want. So in general, when you can use protocols because they're basically better suited for adopting different functionality. The cool thing in Swift is that protocols are very similar to, for example, interfaces in Java, which means they generally just define a contract. But in Swift 2, you can actually even add code to them. These are called protocol extensions, and tomorrow we're going to have a Swift intro lecture and talk more about them. But essentially, it allows you, similar to inheritance, to share code using protocols, but you can basically use multiple inheritance through protocols. So there's a small exercise attached to the end that will basically give you a practical introduction to this, but protocols are often better than subclassing. So to summarize, in general, think about domains when you try to think how to divide your code. What is UI code? What is networking code? What is persistence code? And try to structure it that way. That also will result in each unit of code having at least more or less a single responsibility. Try to not have view controllers that do 5 different things. Try to abstract out the different functionalities. Consider using protocols for inheritance. And also, when you define these different classes that have a single responsibility, then use the chance to define very expressive APIs. For example, the fetch all users API, or the API for the communication that I showed you between the view controller and the database. Try to keep the methods and things that you expose very, very small, and give the methods that you expose expressive functions. That's basically like self-documenting code. If you see fetch all users in code, you know exactly what is going on. Cool. Question? So the question was, if you have a custom UI component, let's say a custom button, and you have multiple of these buttons, where would you put the code to set up these buttons? So I guess the first step, I would put that custom button into a separate class that can handle most of its setup. And ideally, you land in a situation that is very similar to this view object one, where you have basically a custom view, and it just has one single object that the consumer needs to set on it to actually configure the whole thing. Maybe if it's a very complex view, you have 3 or 4 different properties, but essentially you should have the boilerplate code inside of that class encapsulated, and then expose an API that allows you to set the 2 or 3 things that someone can configure about the view.
Okay.
Yeah?
What about animation code? Should that go on a view controller?
It depends. So the question was, animation code, would that go in a view controller? I would say generally not. If it's like a super small animation that takes 2 lines of code, it can be fine. But in general, an animation is something that belongs to a view. Because animation is something that just has to do with representing information, displaying information. So typically, I would try to take a separate view object and wrap the animation logic in there. And the view controller can trigger that animation if necessary, but I would try to put it in the view. It's one of the things that's OK to have in a view controller, but if you're strict about it, it should go into the view.
So you would subclass UI view and then put all the code?
Yeah, essentially, you're always going to subclass from a UI view in almost all cases. So once again, same example. You have this user view that can display a user. If you had animations here, then you would implement the animations inside of this user view directly.
Okay.
Cool. Any other questions? Awesome.